logarithmic form already. So what I have on the whiteboard over here is the index form a of x equals to y, and then changing it to log y base a equals to x. We have certain special logarithms. When our base is 10, we use the common log lg, and then if the base is e, we use the natural log, which is ln. Okay. Also yesterday I made a mention that my L's tend to be inconsistent. Sometimes I write my L this way, sometimes I write my L in the cursive manner. Okay. One important thing that I mentioned before the term ended, okay, last term, but I didn't mention yesterday, was that for logarithms to be defined, okay, your y needs to actually be more than 0, and your base a, okay, needs to also be positive, and a not equals to 1. Okay, what do I mean by log y base a to be defined? It means that for it to be valid, okay, a number that can be computed, alright, your y needs to be positive, okay, that means the big number needs to be positive. Likewise, the base itself must also be positive. Otherwise, you will not be able to get a value, right? So, just for some illustration purposes, some things that are considered good examples of logarithm, maybe you can have log 3 base 2, okay, this is something that you can compute. While non-example wise, okay, if I have, let's say, log negative 3 base 2, it's something that you cannot compute. At this juncture, I have not taught you how to compute yet. Okay, neither have I taught you how to use a calculator, in fact. Okay, there are some rules that you need to learn first before you learn how to use the calculator for us to compute a value. So, this y cannot be negative. Likewise, the base also cannot be negative. Okay, so you cannot have log 3 base negative. These are not valid. Why you come in like that? Okay, so these are not valid, and then also your base cannot be 1. So log 4 base 1 cannot be something that is defined, right?
So I'd like to add on to what I have mentioned in class about the definition, or rather the conditions for a logarithmic expression to be defined, whereby y is more than 0 and a is more than 0 and a is not equals to 1. So as you have seen earlier on in the video itself, in the lesson, I have given these examples and these non-examples. So I want to explain in this very short segment here, why is it that these examples are not defined. So I'll just take one example here first, log negative 3 base 2, to explain to all of us. So suppose that log negative 3 base 2 is defined. When we talk about definedness, what we're trying to refer to is that there is a value that this logarithmic expression is valid. So we let a certain value k be this log negative 3 base 2. So let's assume that there is a value. At this moment, I do not know what's the value. I just let algebraic letter or algebraic constant to actually represent it. So that means that log negative 3 base 2 is equals to k. When we transform this logarithmic equation into index form, okay, index notation, we will get 2 to the power of k to be equals to negative 3. So we get this equation here. But we very well know that for any value of k, be it positive, negative, fraction, or whatever number that you can think of, this equation will never be solvable. Why? Because 2 to the power of k, for any value of k, it will always be positive in value. And then on the right hand side of this equation, we eventually get a negative value. And this defies our understanding of positive definition and negative definition, because how can a number that is positive be actually equal to negative value? That is totally a contradiction which will never happen. So with this contradiction that we face, okay, we see that 2 to the power of k equals to negative 3 is an equation that will never have a solution. And therefore, it makes us bring us to this first statement about our assumption that it is defined. So because of the contradiction that comes out as a result of it, okay, we see that actually our assumption that log negative 3 base 2 is defined is wrong. So therefore, log negative 3 base 2 will not be defined. So what we're doing over here is to prove by contradiction. Okay, is to prove by contradiction to show that log negative 3 base 2 will not be defined. So we can do the same for log 3 base negative 2 and log 4 base 1, whereby we assume that there is a value to it, okay, and then we see that negative 2 to the power of k is equals to 3, otherwise 1 to the power of k is equals to 4. For the statement on the right, very clearly we know that 1 to the power of anything is always 1, it will never be equals to 4, so another contradiction. And then negative 2 to the power of k will also never be equals to 3. So there will never be any value such that k could be for the equations to have a solution. Therefore, in order to define or to make sure that our log y base a is valid, is defined, we need to have the conditions that a is more than 0 and a is not equals to 1, as well as y is more than 0. I hope this helps us to understand the conditions for the definition much better.
So this will help us in terms of answering a question in exercise 5.3, question 9. For logarithm to be defined itself, okay, this x squared minus 2x itself must be more than 0. Okay, so that is how you generate an inequality to help you figure out the range. So if x squared minus 2x more than 0, we observe that it is quadratic. So let's try to recall later how do we solve a quadratic inequality. Chapter 1. How? Before we start drawing your graph, what do we need to do first? We need to factorize now. Okay, so in this case, it's an easy factorization. We observe a common factor of x, so x times x minus 2. Okay, you cannot say x more than 0, otherwise x minus 2 more than 0. That's not true. You need to refer to the graph. Your graph function over here, coefficient of x squared is positive, so it is U-shaped. Okay, and then the 2x intercepts over here, it is when this part is equals to 0, so it's either x equals to 0, otherwise x equals to 2. For it to be more than 0, we're looking at this tail end segments, so this range over here, and therefore x is less than 0 or x is more than 2. Okay, so we cannot discard whatever that we have learned earlier on. Things do come together. Okay, in contrast, let's look at part B. Okay. We have log x minus 3 base x. We want that to be defined. So how do we determine the range of values of x? Okay, I call a name, right? Dash. How do we form our inequalities? X minus 3 is more than 0. Anything else that is important for it to be defined? X also has to be more than 0. So our x minus 3 here needs to be positive based on our definition, and then the base also has to be positive. So there are two things that comes out of it. Okay? Sorry? X must be bigger than 1. Why do you say that? Huh? X must not be equals to 1, okay? But let's just take x more than 0 first. Okay? Yeah. Yes, x minus 3 is the y. This is the base. Okay, so in this inequality here, we see that x is more than 3. And because of this x more than 0, okay, remember your simultaneous inequalities that we are solving in Emaths. Okay? These two inequalities must happen together So x more than 3 and x more than 0, if you recall from the number line, more than 0 is like that, more than 3 is like that. So this is the overlap, and therefore the range of values of x that this logarithm must be in order for it to be defined is such that x must be more than 3. Okay? So x needs to be more than 3 in order for the logarithm to be defined. Okay, so just now your concern about x cannot be equals to 1, it is already being addressed since x is more than 3. Any questions? Right? If not, okay, let's go into the important stuff about logarithms. Values. We need to be aware that log a base a is actually equals to 1 and log 1 base a is equals to 0. Okay, why is that so? It is intuitive if you know how to change it into its index form. Okay, so log a base a equals to 1. If I were to change it in index form, it means a to the power of 1. This a over here refers to the base. Okay, a to the power 1 is equals to a. That's true, right? It's correct. So it's actually about changing from index form to logarithmic form. That's why we can say that log a base a is actually equals to 1. Right? Likewise, this log 1 base a equals to 0 because if I were to change it into index form, a to the power 0 is actually equals to 1. And that is also a fact that we have learned on our 0 indices. Okay? So if you have forgotten about this, you're not sure about it in the exam and all that, okay, don't worry, you can use your calculator to support you, right? If you do not know what is maybe log 3 base 3 or log 1 base 2, okay, you can use a calculator later on once I teach you the calculators. Okay. So taking a look at try 13. Since we have no use of the calculator yet, in this question, they want you to compute or determine the value of this. Okay? How to get the value? So the Bachman's rule applies. We handle the things inside the brackets first, which is everything here. So I'll leave my log base 7 outside. Okay, looking at the things inside the brackets. Okay, 3 log 10. This is your common log. Okay, so common log base 10, right? So actually this is actually log 10 base 10. And that is none other than just 1. Okay, so it's just 3 times 1. Right? So your log 10 has the value of 1. Okay? And then your log square root 2 base square root 2 will also give you a value of 1 because of your special logarithmic values. Okay? Then log 1 is the base of e, it's just 0. Okay? So then we are looking at 3 plus 4, that's 7. So it's actually just log 7 base 7 and that is just 1. Okay. Although later on when I teach you the calculator, surely you can just press calculator for the value. Okay. Now comes all the laws. laws that you need to be familiar with, and it will take practice for you to know it, okay, with ease. Just like your indices laws, okay. So if you're still not familiar with indices laws, it's really important to start revising on that, and practicing that. Okay. So now, the first one is your power law. Don't bother yourself with the name of these laws, okay? Just know how to apply them, that's more important. Okay? I know that there's a lot of algebraic letters over here which might be a little bit confusing, so I'll give you a numeric example. In your very first power law here, we say that log x to the power of r base a. So actually, this, what I mean is that I'm looking at this x of r, okay, as though it is your y over here. Okay, the base is a. When you have a power, okay, to this base, one base only, what happens is that your power can come down. Okay, so power here can come down. Right, so that's what you can think about for the power law. So example. Okay, if I give you log 3 to the power of 5 base 2, I can rewrite it as 5 log 3 base 2. Okay, so the power just comes down. Right? Now, what if I have maybe log 2, 4x squared? Okay, is it right for me to say that it is log 2 log 4 base 4x base 2? Is this correct? No. Why? Because this square, this power is only for the x. Okay? So they are not equal. Okay? I can say that they are equal if, okay, my power is to the entire 4x. Right? So just to be very clear about the power law. Okay? Then next we look at the product law. Okay? Product law, what are we referring to? We're looking at the product inside the logarithm itself. Okay, what happens to it? Okay, it's not very intuitive. It doesn't become a multiplication of two logarithms. It becomes a sum of two logarithms itself. Okay, so what I mean is that if I have maybe log base 2, 3 times 6, I can write it as log 3 base 2 plus log 6 base 2. So long as it is in a single logarithm and I see a multiplication, I can separate them out into two logarithms with an addition. Okay, so that is what the second product law actually means. Then in the third one, the quotient law, instead of product, we now look at quotient and division. So we're looking at, for example, of 6 over 7. If I have log 3 over 7 base 2, it is going to be separated into a subtraction. Okay, so this is what it means. Questions? Okay, we practice practice the laws just to get the hang of it. So let's see, try 14. Okay, let me just group all of them together. Try 14, 15, and 16. We just want to evaluate all of this. evaluate the value of log 27 base 3. Of course, later on, once I teach you the calculator, we can use our calculator. But we are just trying to practice, familiarize ourselves with the laws. Okay. So log 27 base 3. Okay, we have a base of 3 over here. 27, you need to recognize that it is a multiple of 3. Sorry, not multiple of 3. It is a multiple of 3, but it can also be expressed as a power of 3. Okay, so 27 itself is your 3 cubed. Okay, for which this 3 on top can come down. And log 3 base 3 is just 1, so 3 times 1 is 3. Okay. Sorry, in my presentation, I just keep it in that way, but by right, you should do it line by line. Okay. What about 14b? Log 4 over log 32. How? We don't have the law for it. Right? Huh? Bring over to where? It's not equation. Make it base 2. Make the 4 and 32 into a base of 2. Okay? So, we see that 4 is 2 squared and 32 is 2 to the power of 5. Okay? Then what next? Log 2 squared, what can you do with that? Yang Yi, what do you think? You're like twirling your hair, so I suppose there are things going inside as you're drilling your hair into your head. So log 2 base, log 2 squared is log 2 squared. What can I rewrite it as? Is it our last? Oh, okay. So Yang Yi says log 2 squared minus log 2 to the power of 5. Is that right? No, Okay, so observing what I have written over here, the division must be inside one logarithm. One logarithm only. Whereas over here, I have 2 logarithms. So I cannot apply my quotient law. Okay, so this is not true. Alright? Okay? Yes. Yes, so we should actually bring the power down into log 2, sorry, 2 log 2 and then 5 log 2. And that will give us 2 over 5. Log is your log with base E. Okay? So it simplifies to 2 over 5. So when I write 2 log 2, it actually means 2 times log 2. Okay? And then 5 times log 2. That's why I can divide log 2 on both top and bottom. Okay? Log 2 is a number itself. Remember that? You cannot say remove the log. Okay? It's not an algebra. You cannot divide away log itself without dividing the numbers away. Okay? So its function is as a whole. Okay? Let's look at 15a. We have log 4 base 12 plus log 3 base 12. Okay? How? Any ideas? Okay. Jun Heng, what do you think? Huh? Yes, 15A. Log base 12 and then 4 times 3. Yeah. So we apply our product law. Okay, so when I have 2 separate logarithms with the same base, bases must be the same. Okay, and it's an addition in between. We can then take 4 times 3. And this will give me log 12 base 12, which is 1. Okay. Right. Now what about part B? We have log 2 plus log 50 plus log 0.1. How? Oh, what do you think? Log 2? Oh, times 50. Okay, so it's not limited to just two logarithms. So long as it's an addition, okay, we can actually multiply all of these numbers together, which gives us log 10, and log 10 is just 1. Okay, because that is a common log, and it's a base 10. Okay, 16a, log 30 minus log 3. Mel, what do you think? Log 30 minus log 3. Two separate logs for subtraction. Factorize what? LG?
It's the law, it's the law, look at the law.
Cannot factorize LG or
Look at the law.
two separate logs subtracting each other. Don't just see from left to right, see from right to left also.
Log, then 30 over.
Yes. Okay, log 30 divided by 3. Get it? Okay. You see our quotient rule. So that is log 10. Again, it's 1. Okay. And then one final one. I'll speed this up a little. We have log x to the power 6 base 6 minus log 2x squared base 6 minus log x cubed base 6. Okay. You might be tempted to put them all together when you divide by applying your quotient law over here, just like what Earth has proposed to multiply everything. Just that when it comes to division, we just got to be very careful about what we're dividing. So I will actually, in fact, do things one at a time. So I'll have my log x power 6 base 6 minus log 2x squared base 6 transform into this first, putting my log s cubed base 6 on the outside. Okay, and maybe simplify first before I continue to divide. So let me continue here. Continuing over here, I will have log x power 4 So I'll get log x over 2 base 6. Right? Okay. So when it comes to question 16 part B, I'll recommend that you just take it slow, do it step by step. Okay. Try to brush things off. Any questions? Yeah? Right. Now, try 17. We have 5 log x base 3 plus 3 log y base 3 minus 2, and we want to express this as a single logarithm, meaning to say there should only be one log up here. Okay, I'll give you about 2 minutes about that to think about how am I going to transform this into a single logarithm, especially when this 2 over here doesn't have a logarithm in it. What can we do to transform the 2? Okay, think about what is equivalent. Right, give you 2 minutes. Now, just now the hint I gave to you is to think about what is actually equals to 2, right? Okay, what is the most straightforward one? What is equals to 2? 2 times 1, right? Okay, a very, very basic thing. There are things that we take for granted, but 2 times 1 is equals to 2. Right? So remember whenever we do our rationalization back when we were doing certs, we rationalize by multiplying by 1. Just that our 1 is to be expressed in a different manner. Okay? So in this case, it is a strategy that we change our 2 into 2 times 1. Why do I want to do that? Okay, and what's the purpose of having 1? It is because I know 1 is actually equals to log A base A. In this case, because I'm looking at base of 3, so strategically, I want to have log 3 base 3 as my value of 1. Okay, once I achieve this, right, then we can now apply our laws to simplify it into a single logarithm. First of all, down here is x, down is y. There's no way for us to simplify it. We need to bring our 5 up first. And the 3 up as well. As well as the 2. Now that we have it in this manner, addition of 2 logarithms becomes multiplication within 1 logarithm. Then subtraction of 2 logarithm, 3 squared by the way is 9, will give us division. Okay, so this is how we express it into a single logarithm for this question. Okay. Questions? Okay. Next one. Third very important concept, and this is the one where we will rely on in order to use our calculator, and that is the change of base law. Okay, so if I were to be given a base of 3, it need not always be a base of 3. Okay, we can always change the base, right? So in general, how the law looks like, if let's say I have log B base A, I can say log B base C if I want to change the base to C, divide by log A base C. So maybe some of you prefer things to be colored. So E over here. So I have changed, instead of the base of A, the logarithm into a base of C. So what this means is that, as an example, if I have log 5 base 2 and I want to change it to a base of 10, okay, base of 10 is a common log, that's why LG. I will write log 5 divided by log 2. Okay, now why is this important? Because your calculator itself only gives you a base 10 logarithm. Your calculator doesn't give you an opportunity to use a different base. Okay, so they cannot allow you to write in log 5 base 2. Okay, so if I want to calculate what is log 5 base 2, you need to be able to change it into a base of 10. Okay, so to know the value of log 5 base 2, can you press your calculator now? Find the logarithm button. Okay, the LOG. So in your calculator, the symbol, okay, for common log is actually LOG. Okay, so you press the LOG button. And then find then make it into a division of your log. Okay. if I choose the base of e, should I get 2.319 also? By right, it should be. Okay, because it doesn't matter. So long as the bases of the numerator and denominator are the same, okay, they are going to be equal based on your change of base law. So if you were to use ln itself, ln 5 divided by ln 2, so you can find the ln function in your calculator, it won't be the same value. Okay? So you will also get 2.3. Right? So that is how we go about computing, okay, our logarithms. Okay? Any questions? Right. Okay, let's look at try 18. Okay, so try 18 part 1. We are told that A is equals to log 3 base 2 and B is equals to log 5 base 2. Okay, they are all bases of 2, but in this case we have a base of 5 and we want to express it into A and B. So what is the first thing that we should do? Choose another person. Queenie, what do you think? Where's Queenie now? Yes, Queenie. What will you do? We have a base of 5 in this question, and over here we are given base of 2. Yeah, having different bases will cause different numbers, different values. Okay, so based on our change of base law, what will you write? If I want to change into base of 2. You understand my question? Okay. Anybody want to cover? Yes, you see. Log 3 base 2. Okay, over log 5 base 2. Okay, so I have changed over here from an original base of 5, based on my change of base law, okay, to a base of 2 over here. Why I choose base of 2? Because the question gave it to me in base of 2. And I want it to be expressed A and B in the end. Okay, so log 3 base 2 will actually be equals to A, log 5 base 2 is B. So log 3 base 5 is your A over B. Okay? We do another one. Log 225 base 4. What will you do? Winnie, do you want to give it a try? Based on what you just saw. Okay, someone needs to amplify Winnie's voice. Carol, can you amplify Winnie's voice for me, please? Oh, the girls in front. What did Winnie say? I can't hear, neither can I read on this. So I log base 1 2, okay, and then the number here is 225 divided by log base 2 and a 4. Okay, so that will be how we do our change of base now, right? But the problem is this 225 and 4. Okay, it is not in 3, not in 5. So 225, can we re-express it? 225 is equals to what? Can you use your calculator? 25 times 9, forbidden. 225 is 25 times 9. Okay. You all see it now? 25 is actually 5 squared. And 9 is 3 squared. Okay. 4 we will do 2 squared. Okay. Maybe if you want to make sure that you are getting things right, you want to put brackets around 2 squared, that's fine as well. Okay. Erase this part. Now that we have this, okay, down here is a multiplication inside one logarithm. Based on our law, I can separate it out into 2 logarithms of addition. Right? Okay, so log 5 squared base 2 plus log 3 squared is 2. The denominator, okay, is log 2 squared base 2. I can bring the power of 2 down. Log 2 base 2 is 1. So in the denominator, it's actually just a value. Okay. Log 5 squared base 2, power bring down. Okay, we get 2 log 5 base 2 plus 2 log 3 base 2. Right? Okay, so yes, log 5 base 2 is b, so we get 2b plus 2a. Divide by 2. We can divide by 2 throughout the numerator, the denominator. It will just be b plus a. Right? Questions? Let's complete this one last question before we call it a day. Okay, so part A, we want to show that this is equals to. So how do we go about showing? Okay, we need to ensure the presentation is correct. You cannot just carry this whole statement all the way down and then end up 2 equals to 2. Okay, doesn't make sense because from a reader's perspective, from the first statement you're already telling me that they're equal. So of course at the end it should be equal. Okay, so the presentation wise, what we will do is we'll start from the left hand side and prove towards the right hand side. Okay, LHS stands for left hand side. So that is the way to present. Okay, later on when we do trigonometry, okay, presentation will also be this way for proving, especially if it's an equation like that. Right? So left hand side, we are starting off with log 10 base 6 times log 3 base 2 with log 6 base 3 and log 4. Problem here is they are all logarithms multiplying with one another, for which we do not have a law for. Because for separate logarithms, we only have laws for addition and subtraction. Multiplication and division is only found inside one logarithm. Okay? So what to do? Right? Another challenge about this question is that they all have different bases. One is 6, the other one 2, the other one 3, and then this one 10. Okay? Even more challenging strategy because for us to apply any of our laws here, we need to have our bases to actually be the same before we can apply for the base must be the same. So what will your choice of base be if I want to change base? Then, anybody have different options? 2, 10, okay, let's go with 10, right? Actually, I think there's nothing right or wrong, okay, in terms of your bases. The thing here is that you must change to common base. Because if you don't change the common base, you cannot move on. There's no laws that you can apply on. So let's do with 10. Okay, is to change your base of 10, you get log 10 divided by log 6, log 3 divided by log 2, log 6 divided by log 3, and then erase this here. This is just log 4. Okay, when I write this, how would you simplify to the next step? You see, say, can we cancel? You observe that some things can be cancelled out, right? Actually, we're doing division. Okay, we can cancel out your log 6, right? And your log 3. Makes things much easier. Bear in mind, this log 4 is log 4 for 1. Okay, denominator is 1. So that you can see everything in numerator and denominator very clearly. Log 10, what is log 10? 1. Okay, so 1 numerator times log 4. In other words, it is just log 4. Okay, denominator only have the log 2. I'm just intentionally writing 1 in case some of you didn't catch that log 10 is 1. Otherwise, you can write log 4 divided by log 2. And what is 4 expressed in base of 2? Square, right? So, I'm just trying to save space over here, so I'm writing all in a line. So, log 2 square divided by log 2, the square can come down. So, the value is none other than, and this is your right hand side, hence we are showing. Okay. Just because of the whiteboard structure, that's why I write it all like that. For your actual presentation, in any of your work, please write it line by line. Okay. Are you all up for one more? For your quiz, right? Someone said I must be joking. Okay. I'll end here, but I will still give homework. Okay. You want to go and practice it? Exercise 'Y'all learn so many concepts today, leh. Bring up here, this and this. So need to go back and practice what? This part is not you. Wednesday? Next Tuesday? Huh? Why is next Tuesday?
Next Monday,
Cannot Friday, man?
Saturday.
Why cannot Friday?
Saturday, homecoming.
What preparation do you need for homecoming? Okay, so let it be you on Tuesday. Since you want to work on Tuesday,